Okay, so now let us look at a few of true or false problem first. First one, elementary row operation on augmented matrix never change the solution set of the associated linear system. This is a true statement, okay, because elementary row operation is always reversible. So the echelon form or the reduced echelon form is always row equivalent to the original. Okay. Second, the row reduction algorithm applied only to augmented matrix for a linear system. This is false because for the row reduction algorithm, it can be applied to any matrix. Okay, not necessary to be augmented one. Okay. Third one, an example of a linear combination of vectors u and v is z vector 1 over 7u. Well, this is a good one because the linear combination, you can also think about it's a plus 0 times the vector v. Okay, so there's nothing wrong with that. Next one, a vector b is a linear combination of the columns of a matrix A if and only if the equation AX equals B has at least one solution. This is also a true statement. Okay, because you can think about it, this A as A1, A2 as all this column vectors, and then times x1, x2, up to xn equals the vector b. So on the left hand side, you actually can rewrite it into a vector equation, which is x1 a1 plus x2 a2. So this is if it has at least one solution, that means definitely we can write b as a linear combination of the columns. So this is a good one. A homogeneous equation is always consistent. This is also true. Why? Because for any homogeneous equation, it always has the trivial solution, right? So meaning you're going to always have at least one solution there. So that's true. Next one, if x is a non-trivial solution, ax equals 0, then every entry x is non-zero. This is not true. Okay. So even this is non-trivial solution, we don't have any restriction for every entry in x, as long as at least one of the entry is non-zero. So it will be good to satisfy the non-trivial one, right? Because if it's a trivial one, that means that all the entries for x is going to be 0. Okay, so we don't have to make all of them non-zero. At least one of them is non-zero is good enough. So this is false. Next one, the columns of a matrix A are linearly independent if the equation has the trivial solution. This is not true. Why? Because remember, this is a homogeneous equation, right? So a homogeneous equation has always the trivial solution, right? So it's not if it has a trivial solution, it always has a trivial solution. That's one. And last one, every matrix transformation is a linear transformation. For sure, that's a good one, right? Those are the true and false problem. Now let us look at the next problem. So if you have V1, V2, and B here, for verb values of H is B in the plan spanned by those two given vectors. Well, so if B is in the span of V1 and V2, meaning that we can always write a B as a linear combination, right, of V1 and V2. So in other words, we can always write into this. Okay, so we're looking for other some solutions. So if we transform this, so it's equivalent it is equivalent to ask us if this augmented matrix is consistent, right? So if it's consistent, that means that we have at least one solution. Okay, so we can do some the row reduction. So if we use row 2 minus 4 times row 1, that it becomes new row 2. So it's a 1, negative 2, 4, and I have 0. So this is negative 8, right? So minus 3 minus negative 8 becomes minus 3 plus 8, so it can give us is 5. And 1 minus 16, which gives us is negative 15. Okay, I think if we continue to do this, use row 3 to plus row times row 1 as the new row 3, and give us this part is a 0. So this will give us is 3, right? And then this is H plus 8, right? H plus 8. Okay, and then okay, so we can do a little bit more, right? We can do a little bit more. So this part is a 5, this is negative 15. What we can do is we can do this as 1, negative 4, 0, 1, negative 3, right? Then 0, 3, H plus 8. We can continue to do another round of this row reduction. So use row 3 minus 3 times row 2. That is 1, negative 2, 4, 0, 1, negative 3. I think I have 0. This part is 0. So I'm gonna have its H plus 8 minus 3 times row 2. So it's minus 9 becomes this plus 9. So it's gonna have this H plus 17, right? It's plus 17. So as you can see here, what we can tell, if this part H plus 17, it is not a 0, do you realize that? So if H plus 17 is not 0, and then there is no solution, right? There is no solution here. So only when H plus 17 equals 0, and then we have one solution, right? One solution. So meaning that we need to make sure that our h equals negative 17. Okay, so that will give us the solution. Okay, so I'll stop here and then I'll continue.